Today's seminar is about future-proof transport planning, led by Professor Robin Lovelace from the University of Leeds. And I think this is a very convenient seminar for several reasons. One is, especially here, we have some PhD students working in special interaction model and network analysis. But also, I wanted to, just before giving a proper introduction about this seminar, I would like you to join me for a small memorial for one of my friends and colleagues that unfortunately recently passed away. So I want to take just 3-4 minutes to pay a tribute for this colleague. So this is Lorena Abad. She was a PhD student at the University of Sardins. I know her since she was a master's student when I was doing my PhD. And unfortunately, 3 weeks ago, she passed away after a very tragic cycling incident and going back to Sardins from Vienna, attending a conference. As I said, I know her in 2018 when she was organizing or helping to organize a workshop called Open Data for Open Cities. And the picture you see also as her partner. I know both of them, and they are still incredible researchers working in special data science. And coincidentally, she was also part of our Begin seminar last semester. She was telling us about data cubes for vector geometries in R. So you can see the seminar, the slide, and the remarkable work she was doing. And she was also doing her master thesis in cycling infrastructure and study all this transportation model. And I just cannot get my mind around how tragic this one was, especially for the ones who met her. And I think the best way to pay tribute to this amazing researcher is basically check the GitHub repository. She was doing a lot of interesting work and using EO data, remote sensing, obviously sustainable transport. She was passionate cyclist. That's why also struck me quite a lot. And I believe the best way to remember to her name and her work is just going to GitHub account, check what she was doing, maybe take over her research. And obviously for today's seminar, understanding the best way of methods or tools to create our cities and our environment in a more sustainable and safe way is what all this seminar of today is about. So maybe if you can join me for 1 minute of silence. All right. And so Robin is professor of transport data science at the University of Leeds, particularly working in Leeds Institute for Transport Studies. Robin specialized in data science and geocomputation. You probably heard about him, about all these numerous books about geocomputation in R and also in Python. His focus on developing geographical methods applied to modeling and transport system, active travel, and decarbonization. Robin has quite a lot of experience, not only researching but also developing transport models in informed sustainable policies and more effective use of transport investment, including as a lead developer of the propensity to cycle tool. And it's one of the tools I think we're going to see today. The basic of a strategic cycle network plans nationwide. So you will see a lot of things we should actually pay attention to. Robin also has numerous data science projects for organizations writing from the Department for Transport and Transport Infrastructure in England to the World Bank. So for us, for Begin, it's a real pleasure having you today, Robin, and here in St. Andrews. We are blessed with this fantastic weather for this week. We could never take it for granted. So it's very nice to actually cycle from Lovelace to St. Andrews and test out your tool. So without further ado, I think just welcome from our seminars. Please join me with our own applause.
Hey, thank you so much for the introduction, Fernando. And I think it's very fitting that you started with the remembrance of Lorena. I knew Lorena from conferences, and also she did some pretty amazing early work on the level of traffic stress research. She was an amazing researcher, and I collaborated with her on the SF Networks package. So I think it's really great that we remember her, and thank you for everyone for taking that minute of silence. So that's a kind of sad note to start with, but I think it is important to remember her, and hopefully this seminar kind of is partly in her memory, and it's the kind of thing that she would like to see happen. I'm going to be talking about my work, and this is also in the build up to a workshop that I'll be presenting on origin destination data. I'm going to start quite broad with a bit of background. As Fernando mentioned, I recently had to deliver an inaugural lecture at the University of Leeds, and that made me kind of reflect on the journey that I'd taken. So I'm going to talk a little bit about the journey that got me here, the kind of things that I'm interested in. And I also want to spend some time talking about future ideas for research, and also to think about what we as a community need to do to make our work future proof. And by that, I mean that we don't just write a load of papers that get forgotten about and nothing changes. So by future proof, I'm linking that concept of future proofness with having some impact outside of academia as well. So I do want it to be a conversation. If anyone's got any questions at any point, just put your hands up, and I'm going to go into the slide deck. So yeah, as I say, I'm going to talk a bit about my background, some of the current work that I'm doing, and also trying to define the work that I'm doing in terms of transport data science, but diving in a bit more into what that actually means. So data science is almost ubiquitous as a word, but I hadn't spent much time thinking about what I actually mean by that term. And I think there are some important lessons when you start trying to define data science. I'm going to talk about the network planning tool for Scotland, which covers this area. So we can have a look at that and think about some of the steps that went into building that tool as it relates to the research. And then I'm going to talk about some future ideas that I'm interested in working on, but I'd like to hear from you guys what you think are interesting ideas, and I'd love to hear from people in the audience as well. So I'm not going to read out this long abstract, but basically it's about transport planning, and it's about using new research ideas to inform transport planning and make positive change happen in the real world. So very briefly, in terms of my journey, it's represented on this interactive map. I started off in Hereford, and it's the bottom left of each word, which is roughly the location. So this was quite a rural place. I actually had the opportunity to do my undergraduate to go to university in Scotland. I had an offer from Edinburgh, but me and my dad drove all the way from where I'm from in Hereford. And it took about 6 hours. And I just said, I never, ever want to do that again. So for that reason, I took the easy option and went to Bristol for my undergraduate studies. I wonder if there's something about that experience that has led to my research into sustainable modes and not car transport as well. Yeah, I did environmental geography, and I really enjoyed that program because it allowed you to take bits from physical geography, so atmospheric physics on one hand, but also the more social sides. And I've always loved this definition of geography as combining the kind of physical world with humans in the world and that interface. And that's something that some of the early geographers, including Alexander von Humboldt, they really understood that. And they didn't make this distinction between, oh, you're a hard scientist, you do physical science, you're a real scientist versus you're a social scientist or whatever. It's all the same system. And I think it's really great, some of the work that's being done in St Andrews on ecological modelling. And I think there's an interesting story that Erska talked about at a recent conference about bringing ideas from ecological modelling into modelling human transport systems and vice versa. So it's great that we can have that kind of dialogue. And I think St Andrews is a great place to do that. One of the reasons that I chose Bristol, in addition to it being closer to where I'm from, is that they offered a year study overseas. And so I did 2006, 2007, I did an Erasmus year in Salamanca, and that was amazing. It kind of opened my eyes to the fact that there's a whole world out there and really got me very interested in generalizing ideas and trying to find solutions to global problems. And then I went back to Bristol and I applied for a few master's courses, and I got a fellowship to do a master's in York in environmental science and management, because I think I was very interested in the atmospheric physics side of things and the environmental side, and I just thought environmental science is a good way to do that. And when I was in York, I became very, very interested in the concept of energy. All of the problems that we were looking at, including air pollution and social issues, seemed to be related to energy use. So I became extremely interested in energy use. And because of that, I ended up applying for a PhD program at the University of Sheffield, where I was part of the Energy Futures Doctoral Training Centre. And that was an interesting experience for me because, unlike previously, I was surrounded by physicists, chemists, engineers, and I was almost like the token social scientist. So I had to learn a lot in that situation, but I honestly found it very helpful, and the kind of level of rigor and the need to quantify and define the question was extremely interesting. And so I did my PhD in energy and transport at the University of Sheffield, and then I got my first postdoctoral job in Leeds, and I haven't really moved anywhere since then. So it's not a very interesting map since 2013. But Leeds is a good place for my interests because it has computer science, it has data science, it has a strong geography department, and it also has a very strong and high impact transport studies department, which is where I'm based now, which is the Institute for Transport Studies. And as someone who likes to think that my research has impact, it's perfect because they work closely with governments, and they do a lot of work making transport plans happen in the real world. So I'm not going to go into the real details of where I'm from, but basically it's a fairly rural place, and that's definitely influenced my way of thinking about the world. I'm not going to talk about Bristol. I think I've already touched on it. These are just some photos that I took of places that I've lived. I did mention the interest in energy, and one of the books that got me really fascinated and passionate about energy is this one, which is Sustainable Energy Without the Hot Air, which is by David Mackay. And at that time, and still now, there's a lot of rhetoric, there's a lot of opinions around this topic. And what's great about this book is it says we should use numbers, not adjectives, to describe the situation. So it's available for free online. So if anyone would like to kind of learn more about the energy system and ways of communicating it, I can really recommend that book. And that way of thinking and simplifying problems, but also quantifying them is a really good thing to do. The other image in this slide just shows my interest in peak oil. And I probably spent too much time reading blogs at that time about peak oil, and I ended up contributing to some of these. But I've always had like an interest in stuff outside of my academic work. And in this case, I wrote a blog article about how to set up and run a bicycle repair company, which is, I found that a very tangible and meaningful thing that I could do, perhaps because I was slightly frustrated that all of this research that I was reading about didn't seem to be going into the real world. Whereas if you go out and fix some bikes, you can actually see some change happen in the real world. While I was in Sheffield, I was involved in Engineers Without Borders, and that was interesting, but I don't want to dwell on that too much. I think a good thing to starting point in terms of the academic work that I've been involved in is my thesis. So you can see the title there is basically a simple question. How much energy do we use, not just for traveling, but for the specific purposes of getting to work and back? And then let's invent a really complicated or use a complicated method to answer that simple question. And it was a good question in some ways, or it was a good approach because it forced me to learn how to program, because there was no way to implement these ideas without writing some code. And it also led to me coming up with some ideas about how you would model this if you had all of the data and all of the compute power that you wanted. So this is just a figure from my PhD thesis, which I didn't actually implement this. This is what I would do if I had all of the data and all of the time, but I don't have time, but I'm just going to do parts of this. But I think what's interesting about this, reflecting back on it after 10 plus years, is that this is actually doable today. We can genuinely estimate a transport system in this much detail and implement that representation in open source software such as Matsim. So I'm not going to dwell on it, but basically this idea for a comprehensive commuting energy database, you have people ID, and then each person takes a number of trips, and then each person is associated with one or more vehicles, and that vehicle has a make, model, purchase date, and then from that you can estimate the level of energy use. And then you link this to transport models, which include the mode of transport, the distance, you need trip frequency, and then you can start calculating the energy. And one of the things that I learned from the Energy Futures PhD program was that energy isn't just what you use at source. It includes the whole life cycle. Energy use includes like manufacturing the vehicles, manufacturing the roadways. So it was basically trying to understand the system in as much detail as possible. But the problem that I hit with this is that it became impossible to run this at a national scale. And I think unless your research can be run at a national scale, it's hard to influence national policy. And the big decisions around transport and other things tend to be made at a national scale. So I essentially realized that this approach wasn't going to work if I wanted to generate things that ran nationally. So I completed the PhD, then I moved to Leeds, and then this is where I got interested in one of the things that I'm going to be talking about in the workshop after, which is spatial interaction models. So unlike the spatial microsimulation and agent-based models that are represented in the previous image, spatial interaction models are simple and they can scale quickly. And instead of trying to use individual data and modeling everything on the individual level, you can aggregate and you can just count the number of trips between zones or between other spatial entities. And the nice thing about that approach is that you can really you can look at the whole transport network at a distance. You can run a model quite quickly and come up with an answer. So this was actually the first research output that was fully written in Leeds. And interestingly, it never actually made it into a publication. It's still a preprint knocking around on archive. It's picked up a few citations, but it was an interesting paper that was looking to use, at the time, new social media data. So that the top image on the left shows estimated movements that can be converted into origin destination data from tweets about museums. And then the bottom one represents a spatial interaction model that we trained using that data. So from a methods perspective, I found this absolutely fascinating. I was loving it because it gave me an opportunity to learn all of these new digital tools that were emerging, including the R package ggplot2, which I used to create the images on the right-hand side. And I was doing a lot of methodological work and learning a lot about programming and data science. But I didn't really feel that fulfilled in terms of what am I doing with my life, because modeling trips to museums isn't really world changing. So again, this is another side project. It wasn't linked to my main job, but I did some work trying to help Cycling UK, which is a UK charity for cycling. And they said, well, we need some models to try and estimate the potential benefits of having more ambitious plans for cycling. So I did a little bit of work using some of the ecological models and kind of logistic growth curves, and trying to come up with like very ambitious, but also like not completely impossible scenarios of growth for cycling, and doing that for like just on this as a side project, as an unpaid piece of work. So I was interested. And interestingly, that side project kind of became the main thing after some time. So this work was used by Cycling UK, and I think it probably had some influence. It's difficult to know how much difference it made, but it certainly fed into Cycling UK's feedback to the government's plans, and it was used as the basis to make the case for more investment at a national scale in cycling. So I found that really rewarding. I also did some work with James Woodcock, based at the University of Cambridge, and with Fiona Crawford, who's based now in Glasgow, on quantifying the benefits of cycling. And it was it was really nice to be able to apply the methods that I'd learned to something that I really cared about. And this eventually led to me, I think, getting my career break probably was when I became the lead developer of the propensity to cycle tool, which Fernando mentioned in the introduction. And this was actually commissioned. It was a commission by the Department for Transport. They put out what's called an invitation to tender, where they ask companies to tender, to say, like, to put in bids for it. And I knew someone from outside of academia gave me a heads up that the DFT was commissioning this, and they said, it sounds a bit similar to the ideas that you're talking about an algorithmic way to decide where to build the next cycle path. Unfortunately, we couldn't bid for this thing directly as academics because it was only available to companies. So I contacted academics from various universities, and thankfully James Woodcock at the University of Cambridge got back to me and said, yeah, we can do this. And we contacted a company to say, well, can you kind of submit the bid on our behalf, but we'll do like a lot of the legwork. And to our surprise, we actually won the bid, and that led to the propensity to cycle tool, and many other things have come from that from that experience. So I guess that if there's a lesson from that, it's side projects can be really good and do follow your interests, So that was how I got into strategic cycle network design. There's a lot I could say about that, but I think, and this is now deployed, it really does have impact. So I've ticked the box in terms of wanting my research to have impact. I would say sometimes I feel like I would like to do more of the more theoretical and methodological work, because a lot of it is really applied and quite heavily on the kind of almost consultancy side. But yeah, I got to present this tool to the then Secretary of State for Transport, and this was the basis of a ref impact case study, which if you're an academic, you know this, you have to spend ages filling in these forms, telling people about the impact that you've had. I'm not going to talk too much about the internship in number 10, but basically my interest in policy led me to apply for a fellowship with the data science team in number 10. So this is directly providing guidance to the Prime Minister and his team in London. And I did some work there with Federico Botta, looking at journey times. And we were basically trying to make the data sets that different parts of government held more accessible across government. And then that led to me working for 2 years for Active Travel England. So Active Travel England is a new government agency tasked with basically providing the evidence and also distributing the funding needed to get more people walking and cycling. So my roles in that team was primarily to recruit the team. So I spent a lot of time doing job interviews, writing job specifications, and then setting out a bit of some ideas of what we could do. And I'm very happy to say that our work, some of the work that I started there, this was another demonstration of a prototype version that was we presented to the then Minister for Cycling, Jesse Norman. And there's a good link back to Hereford there, because he was the MP in that area. And we got him to imagine that he was designing new active travel routes in Hereford. And we also have now deployed this web application that's hosted on gov.uk. And I would happily do a demo to people that allows you to not only see data on active travel and see what the potential could be in the future. That's what I've done in the past, but it goes way beyond that by allowing anyone, members of the public or local authority transport planning staff, to plan their own routes. So I'd love to do a demo of that. So in terms of what I'm up to now, there's quite a lot of time spent on the family matters. So we've got a baby there called baby Rosa and Kit. And I joke saying that I can do some research into how young can you get away with having a child in a bike trailer. And yeah, I'm spending a lot of time just on family matters at the moment. But I'm also back to full-time in academia. So it's a good time to be thinking about what I want to do in the future. So essentially, yeah, my role is Professor of Transport Data Science at the University of Leeds, as Fernando said. I want to focus on high impact, meaningful research. I'm doing teaching on data science and teaching the practical elements of it. I need to play the game, so to speak, in terms of grant funding and trying to succeed in academia without retreating up the quote ivory tower to focus on impact. And the image there shows a couple of ivory towers. I never knew what the kind of origin was, but apparently there are actual ivory towers in Oxbridge, and I want to ensure that my work stays relevant. So changing track a little bit, I want to talk about my job title and specifically the data science aspect of it. So it was only a few months ago when I examined a PhD thesis that I revisited this idea of what does it mean to be a data scientist. And this was actually from Anastasia Vibanova's PhD thesis, that she picked up on the fact that the origin of data science is actually commercial. It's not from academia, it's not from research. it was people who were working in big tech companies who were basically defining it and saying, we've got this thing, but they were very much framing it as something that you do in industry to make money. And I think that was a bit of a kind of moment for me to think, oh, okay, well, I didn't realize that that was what I was doing. But I think it's important to recognize that history because you don't have it in geoscience. Geoscience, I think, you would say it's more of an academic field, although it does have a long history of application. And then that leads to this debate of, well, what actually is it? Is it statistics plus machine learning? Is it statistics plus computing plus communication? And you can keep adding on disciplines. So that made me want to actually define it. So in terms of my work and how I like to define data science for transport or transport data science, I can take previous definitions. So data science is a discipline that transforms raw data into understanding, insight, and knowledge. So that part of it is on what you're doing rather than how. So that shows that it's really a practical, hands-on discipline. I definitely think it's important to add on the reproducibility element of it. So with reproducible and therefore falsifiable and therefore scientific and scalable code. And I think that's an aspect of data science that's often missed. And then in terms of the transport side, I define it as doing those things for better understanding of and interventions in transport systems. So it's not just about understanding them, it's about understanding how they could change in the future to inform policy. So that's what I want to do. And if anyone's in doubt of whether or not you should bother to make your work more reproducible, because it's not like you're zero reproducible or you're fully reproducible, as the continuum at the bottom shows, everyone can make their work a bit more reproducible. I would just like to say there were big benefits of doing so. And that's something that Lorena and others in that field have really pushed that aspect of research in a positive direction. So yeah, there's some benefits of being more reproducible. Yeah, and I don't think I'm not encountering anyone shaking their head saying that I don't think we should be more reproducible. So I don't think I need to talk about this slide as to why not. But if anyone asks, there are kind of counter arguments as well. So I've got one example of fully reproducible research, and I think what's good about reproducibility is it kind of forces you to generalize your work. If you have a one-off script that does something, it might run on your computer today, but is it going to run on someone else's computer or even your own computer on another day? And if you want to generalize it, that tends towards packaging things up in digestible chunks that other people can use. So you end up writing code not just for yourself, but for other people. And a logical destination for that journey is towards actually writing open source software, which is a great thing. There are great communities around open source software, including the communities that Lorena was involved in. And just one example of this is the Spanish OD data R package. So this was instigated by someone called Egor Kotov, who's the lead developer and leader of this package. But I was very interested in the work that he'd done to kind of download it. And he was just doing that script as like one small part of his PhD. But I said to him, this would be so useful for many other people. And long story short, we ended up collaborating on a package. And now that package is not only on CRAN and available to download, but it's also hosted by the R Open Spain community for encouraging people to work together and support each other in building open solutions. So that's one example. One thing to say is that making your work open source isn't enough in itself to ensure that it has impact. So most people aren't programmers. Most people don't even know what R is, let alone know how to install a package and use it. So I think the next step after that, if you really want to make your work accessible, is to go beyond open sourcing your work to making it accessible. And I've just got this quote from a paper by myself and others on the definition of open access transport models, where it's talking about taking that software and building a community and making it more user friendly. And I think, to be honest, the best way that many people can do that, if you are technically minded, is to build a web application, because people may not be writing loads of lines of data science code, but anyone can use a web application, and basically everyone has access to the internet. So that's just one thought for people to think about. Would it be possible for you to convert your research findings into a web app one day? So that's a question for others. So in terms of the future, I've got a few ideas that I want to share, and I also want people to share ideas with me and open it up for questions. So I'm not going to go at length on what I'm thinking in terms of future research directions. What I do have is some principles that I've been thinking about in terms of what I want to do. So given where we are, and I think in terms of research, we are in a much better place than we were around 20 years ago when I started getting interested in this space, in terms of like availability of data, availability of software is actually really good. And if people complain about, oh, it's difficult to use this package, 15 years ago, the only way to get any kind of guidance on something was to look up these obscure forums and physically email people who may or may not respond with some code. So we're in a pretty good place in terms of the technology. And I would say that open source software is actually thriving. There are loads of open source software tools. So the good news is you don't need to reinvent the wheel. You can probably find an existing open source software package that can do what you want to do. So the first thing to do is like think about, do I need to build my own thing from scratch, or should I join an existing package and help someone else with their work? And then how can I make it better? And one of the ways that we can make software better is by making it faster and hopefully more efficient. And I'm not just saying that because it's fun to do things quickly. If your code runs quickly, that can actually be really important in terms of its level of accessibility. If it runs efficiently, you don't need to spend loads of money on a big computer to run it. And also you can do more experiments. So rather than running a single experiment that takes a day, why don't you run like 50 experiments, all with different scenarios and different parameters, and look at the result, even if the results are less specific. So that's that kind of generality and ability and to test different scenarios is something that I'm really interested in. Making transport planning software and data science tools more gamified, responsive, and accessible is definitely something I'd like to do. And then also higher resolution. And I think higher resolution is important because if you want to cater for active modes like walking and cycling, you need the level of detail that goes right the way down to pavements. And I've got one example here, which is on the bottom, shows a scenario where they replace 50% of available road space for cars currently to space for walking and cycling. And I just think that level of ambition, that simplistic scenario that you can tell to someone and they'd understand it, and then implementing it is a really great way to do bold research that is backed by data. So yeah, I've got a couple of plugs in here. One is for the AB Streets low traffic neighborhood tool. Another one, which I think represents this idea of having a simple scenario but a detailed implementation, is Kai Axhausen, who's going to do a talk at the University of Leeds. But in terms of my own research areas, I'm interested in seeing what works for active travel. So we've got loads of data on interventions where people have built all different types of infrastructure for sustainable transport in general. And I got to cycle on some of it when I was coming from Lucas to St Andrews, but we don't actually know which ones work. And in order to know what kind of interventions are effective, we need way more data. So the good news is there are already people working on this. So this is a map from a website telram.net, where they are basically crowdsourcing count points. And each of those points gives you a lot of information, how many people are passing that road per day, and broken down by walking, cycling, and motorized modes. So I would like to roll this kind of thing out at scale in England or internationally, and start analyzing the data to understand what works for active travel. So that's one idea. Another one is actually something that I have been working on for a long time, and I should have completed by now. So when I was in Active Travel England, I was working on a school routes project, and it's frustrating that it's still not available because it's such a common problem that kids can't get to school safely. And this photo was taken in Bristol, where my friend takes their daughter to nursery on a bike, and they're lucky because just around the corner they get onto a park, and the majority of the road is safe, but just that little section, they either have to go on the road or go on the pavement where it's actually illegal to cycle. So that's something that I'd like to work on. And then more blue skies. This is a bit of a kind of vaguer idea, but the basic idea is to have a global model that is generating like baseline data on the transport network globally. So a little bit like how a global circulation model in atmospheric physics is like a baseline climate model, I would love to have a model that then other researchers can use, that's like a simplified representation of the transport network, and people can take it and build stuff on it. And there are indeed people working in this space, but it's just something that I find fascinating. So yeah, those are some ideas that I've got in terms of recommendations for anyone wanting to get involved in this space. As Fernando mentioned, I've been involved in generating accessible teaching materials, so geocomputation with R, and now we have recently published geocomputation with Python, and those are accessible. They're online and open source books, so you can go and check them out. And in fact, the workshop that follows this seminar is going to go into the details of some of the kinds of code that we'll be using, that we cover in geocomputation with R. I'm a massive fan of sharing your work, not just your papers, but also your code. And GitHub is probably the number one place to do that. So if you don't have a GitHub account, definitely sign up. If you do have a GitHub account and you haven't looked at it, you can actually use it to start asking questions and get involved in these open source communities. And also, it's not just about the code, developing and sharing ideas, and just coming up with new ideas and thinking about how could this be different, or finding bugs in existing projects and trying to work out ways to fix them. So one final plug I've got is if anyone's specifically working in transport planning, I'm going to be delivering a 2-day workshop on data science for transport at the University of Leeds, and that will be on the 18th and 19th of September. And it's kind of angled towards practitioners, but I think it would be very useful to academic researchers in this field as well to improve practical data science skills. So I know that I haven't actually answered the question of what is future-proof, but I think some of the themes there are that if you make your work more accessible and open, then it will allow people in the future to use them, regardless of the direction of travel in terms of political priorities or in terms of available data sets. If you put your work out there, then that's a foundation that will be used regardless of events that cannot be predicted in the future. So hopefully that's a good summary of my research and my interests. As I said, I'm very interested to hear what people think and what research priorities people have here. So any questions are very welcome.